All right, students of marine science, I am back for lesson 4 of unit 3. So this is your 3.4 lecture, salinity and dissolved substances. We've talked a little bit about salinity already previously in the unit, and now we're gonna kind of go a little bit more in depth about how that relates to the ocean. So the chemical properties of ocean water or seawater are very different from that of fresh water, and that creates very different habitats. So salinity is one of those chemical properties of the ocean water, but that's not the only thing that we have going on. So water acts as a really incredible solvent. In fact, it's often referred to as a universal solvent. So the water is really good at dissolving salts, as some other things as well. So salts are made of ions. You're not writing any of this down yet. We will get to your answer for number 1 in just a moment. So salts are ions, and the ions in salt, they pull apart or dissociate when the salt dissolves in water. So how do all those salts get into the ocean in the first place? We know that the ocean is very salty. Well, the main way that they get there is through runoff. When rain washes down land, and as it does, it picks up dissolved substances, lots of salts and minerals that are on our rocks and just all over the place as that, on our streets and in our grass and soil. So as rainwater is rushing down all of these things and eventually working its way to sea level, it's picking up a lot of these minerals and dissolving them by the time it gets out to the ocean. The other way that some substances would get into the ocean is through what's called outgassing, which is the release of water and other substances from the Earth's crust, so primarily through volcanic activity. So this can happen in like on land, or it can also happen in the water, in the ocean. This outgassing, releasing of minerals and materials from the mantle. Just an image here of kind of how that process works, the water cycle of being evaporated and then condensing, and then the precipitation and rainfall comes down. And wherever that rain comes down, gravity is going to do its job and ultimately try to pull that water back to sea level. Most of our rivers, many of our lakes are all connected through rivers, and that water eventually is all trying to get back to the ocean. Number 2, what is a solution, what's a solvent, and what's a solute? We're actually, none of this was in bold, but we're defining all 3 of these terms. So if you see a way to abbreviate it, feel free. But in other words, otherwise, we're going to go ahead and just define all 3 of these. So a solution is a homogeneous mixture, just a mixture composed of only one phase of matter. In water, we're talking about liquid. That's what we mean by a phase, either liquid, solid, or gas. So water dissolves these other substances into itself. These other substances are called solutes. So salt is a solute that gets dissolved into the water, which is the solvent. So the solvent is the thing that does the dissolving. So the salt is the solvent that the water is the solvent that dissolves the solute, which is the salt, to form a solution, a combination of these 2 things in a single liquid phase. See some sodium chloride here breaking up and dissolving into the water. 3 says what is an ion, and then it says sodium and chloride account for what % of the ions in seawater. Just focus on this red part here. So an ion is an atom or molecule in which the total number of electrons is not equal to the number of protons. So that means it's going to have either a positive or a negative charge. So the red part here, particle with a charge, either positive or negative, it's going to be referred to as an ion. We're not going to worry about ionic bond. If you want to pause it and read that, you're welcome to. But you don't need to write anything down there. So most of the solutes, or the dissolved materials, are made up of a number of small ions. Really, we just want to focus on the bottom part here for our purposes today. That sodium and chloride account for 85% of the ions in the ocean water. The sodium and chloride, these salts are the main thing that gets dissolved. There are lots of other things too, but most of what's there is sodium chloride. Again, another image of materials entering into the ocean. The precipitation is another way that it can happen as well, particularly from this outgassing. It picks up materials and drops those materials into the ocean through precipitation. Number 4, we've been using the word salinity already, but I think I told you that we would eventually define it later. So salinity is the total amount of salt dissolved in seawater. It's usually expressed, just write the bold part, I'll walk you through the rest. It's usually expressed in a number of grams per 1,000 grams of seawater. So if there are 35 grams of salt water that are found in 1,000 grams of seawater, which it tends to be about the average, then that seawater has a salinity of 35 parts per thousand, or 3.5%. So about 3.5% of our ocean is salt. That's about how much of it is salt content. The relative percentage of the major ions in seawater remain constant, even though the total amount of salt may vary from place to place. Meaning you may have a little bit more salt here, a little bit less salt there, but overall the amount of salt within seawater stays pretty much the same, which is referred to as the rule of constant proportions. Not something that you need to have memorized, I just wanted to mention it. The saltier the water is, the more dense it is. Again, this is review from a previous lesson. So the density of seawater is going to depend on temperature and on salinity. Temperature varies more than salinity does. The amount of salt in the ocean is relatively stable throughout most of the ocean. Temperature is not. And so since temperature can fluctuate so much, that's going to be the main thing that determines water's density. Remember, cold contracts, heat expands, and so the colder that water is, the more dense it's going to be. Density tends to be more related to that temperature than it does salinity. Salinity does make our seawater more dense than things like a freshwater lake. Lots of gases are dissolved into seawater. Oxygen, carbon dioxide, nitrogen is things that are in our atmosphere that get dissolved into the ocean. So gases from the atmosphere dissolve into the sea. Sometimes the reverse happens. Things from the ocean are soaked into the atmosphere. But the ocean does a pretty good job of soaking things in from our atmosphere, which is not always a good thing. As far as heat goes, that's a very good thing. But as far as the health of the ocean goes, this can be very detrimental to it. Since about 1750, and particularly since the Industrial Revolution, human activity has caused atmospheric CO2 levels to increase drastically. CO2 levels continue to rise, are higher than they have ever been, probably for at least the last 800,000 years. In fact, we will talk about this much more at length in another lesson, really just introducing this idea of CO2 levels being on the rise to get to this part, acidification. So acidification it has to do with the pH level of the ocean. As this rising CO2 level continues to go up and up, then it's impacting the chemistry of our ocean. So the pH of the ocean is dropping. If you look at it, the pH scale, it starts at 0 and you go up to be more alkaline and down to be more acidic. It is becoming less alkaline, becoming more acidic. So the process of the ocean becoming less alkaline is called acidification. And for the last part of our question there, what percent of CO2? It's roughly 30% of the CO2 that gets emitted into our atmosphere every year is getting dissolved into the ocean. That 30% is a significant amount. That is a lot of CO2 that we are putting out into our atmosphere, affecting it in negative ways, but then in turn also having a negative impact on the ocean, that 30% that it takes in. So I do want you to jot this down too as a part of number 6. This is the last thing you'll write, I think, yeah. So the organisms at the most risk of acidification, or things that are in the most danger because of acidification, are anything with a shell. Things with skeletons are negatively impacted as well, which is most everything. We can think of some examples that don't have skeletons, things like octopus. But a lot of what we have in the ocean do have these skeletons, but particularly things with shells, with that outer kind of calcium-based shell. They have a hard time. They have to put a lot of energy, and because of acidification, they have to put even more energy into trying to build their shells, and that takes away from their ability to do things like eat or reproduce. And so it has a very negative impact on those species, and when those species are negatively impacted, the entire food chain gets disrupted. Not only are the things that have shells negatively impacted, there aren't as many of them because of acidification, but then the things that eat the things with shells don't have as much to eat now, and so there aren't as many as them. And the things that eat the things that eat the things that eat the shells. There's all the way up the food chain, all throughout the food web, all of it gets negatively impacted, including things like humans on land who rely on some of these marine species for part of our human diet. So lots of negative impacts that come from this acidification. So last thing I'll mention here, you don't have to write this down, but particularly marine larvae. This is something that has been very, very negatively impacted. Young of many marine species that have a larva phase as they're trying to grow and develop. They just have a very hard time doing so in a more acidic environment. It also can suppress the immune systems of many animals, can alter the behavior of some animals, kind of make them kind of irritable and uncomfortable in that more acidic environment. There's all kinds of problems that are caused by this acidification, and something that, as the cause of most of this acidification, we humans need to be taking very seriously. We'll leave it at that for Unit 3, Lesson 4. Peace.